look at number 28, implement string. So actually, we need to find the first appearance of the needle. Yeah, the string we're to search. It's like the JavaScript version of index of. Yeah, and when needle is an empty string, we need to return a -1. So I think we need to do it first is just do it in a naive way. First, we loop through all the characters in the haystack, and then try to match the needle. That will end in. Let's just yeah, match the needle. If we find that needle is matched, we return index. If not, we continue to the next characters of haystack. So okay, for the parameters, the special case is that when needle is empty, if needle is empty, we return 0. Okay, for each character of a haystack, we try to match the needle, right? So let j equals 0, while needle j equals haystack I plus j. Yeah. If the characters are matched, then j plus equals 1. And when the needle ended, okay. We return I. If the needle is matched, so that means if okay, needle length. Okay, if j equals needle length, which means the needle is fully matched. If that's the case, we return I. If okay, we don't read if. Return I, and if not, we just return -1. So this should be working. Here, the complexity here, and here, OM. Submit. Yeah, it's accepted, but maybe we can do some improvement. So how can we improve? Let's try to find the improvement by looking at the real situation. Let's say we A, B, C, D, G, E, and we're trying to add match A, B, C, D, E, G. First, we match this, compare this A, B, B, C, C, D, D, right? So it's true. And the next one, we compare G and E. They're different. So for our naive solution, we just move it one step further for the haystack. So we'll compare BA. But BA is not different, so it's not same. We move it further. But if we take a look at it this way, if there exists a place that we matched here, like here, then it should be A here, right? But these already matched in the starting 4 characters of the needle. This is haystack. Yeah, that means there should be A here. That will make the assumption not right, right? So what I want to say is, if the characters are totally different, here we can safely jump directly here to compare for the first one, right? Because if it's not, then this one must be A, and correspondingly this one must be wait, this one must be A, so there couldn't be any characters there. But what if there are like some characters there, like A B C B G and A B C A B G A B C A B D. For the case here, G D, when we want to try to move, we cannot just compare the first one, right? We can, because there is an A B here. We should compare A B here and see if that it match, right? Because yeah, if it is G here, if it's G here, you see, if we jump through here, it doesn't match. But actually, it can match like this. This gives us the an idea that actually, if some characters are not matched, like this for this one, for the G V versus D, we can jump straight through the character, move to the character where the last characters are the same as the starting characters, right? So it's not perfectly right, but actually we can jump through the next A, right, where A is, and move it there. Of course, it's not 100% right, but it basically is something like this. We can skip to the characters here. If we just jump through the next A, it will improve the naive solutions a little better. So the problem becomes, if we find that the characters not matched, how far we can move to how far we can move to the next step. In that case, actually the haystack is not how to say, it doesn't matter what haystacks look like. We just need to advertise the needle. Like for D, here is AB, here is AB. So next time, if we if some characters doesn't match on D position, we can just continue matching, just jump to C. Right? So actually, let's take a look. Let's look at it at another way. A B C D E, and here is A B C D G. It's totally different, right? So when we're comparing, there must be a cursor in a haystack and a cursor in a needle. If the cursor is currently in E and G, when it is not matching, because these are totally different, we would move the cursor of needle to A and make them compare, right? But if there is some characters like duplicate, like this time, we couldn't move G to A, but move G to C and compare it, because compare ABE to ABC, and then if that's not true, we fall back to 0, right? If compare 0, if it doesn't match. Okay, so the last step, so if the first letter doesn't match, like CA, if the first letter doesn't match, then we should move the cursor in haystack. You know, so the step in G, in needle, the needle, our improvement are actually improved while loop here. Like for the naive solution, we compare, like for this letter, okay, match, match, match. If not, we move to the next one, match, 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 match. But now, if it is matched, okay, we continue to the next one. But if it is not matched, like G here, we would not, if not matched, we would not compare like go to the next one, compare like some G, E, F. We just go to C, like this, and we will have a possible match here. Easy, right? Yeah. Yeah, ABC. Yeah. Well, we are doing a while loop in the first naive solution. We will keep the cursor in the haystack the same. That actually is not very performant. In a second solution, we are moving it together. Okay, so what the problem becomes for a needle like this, we need to know if we made some characters that we didn't match some characters at specific position, how far he can move to the next step. Yeah, let's say there is a jump step array. Let's say if there is a jump step, how would this help? Okay, so that will be, we will move them together. I equals 0. Let j equals 0. While I smaller than haystack.length and j smaller than needle.length. If they are the same, right? Haystack I equals needle j. So if the like A B C A B E, if they're the same, we just move to the next one. Okay, so I equals 1, I plus equals 1, j plus equals 1. Now, if we match one, if j equals needle.length, we return I must be the one after the needle, so we turn I minus needle.length. If they are not the same, just as we talked before, we will move the cursor to the next position, which is the length of the maximum length of the string, which is the both at the end and at the beginning, right? So for this case here, we will jump to C, which is the for index, which is just the length of the substring. So we will, if not the same, if they're not the same, but for k, but if k is already at the beginning, they should move I. So if j is bigger than 0, then we move j to jump step j. If it is 0, we move I to the next one. So this is done. So next step is okay. So here this is O N. There will be some extra computations in this else if, but it's constant. So this will be O N. So next one is how we can calculate this jump step. So okay. Okay, so basically, if we want to get the jump step of this needle, our naive solution says find the next A and just try to match it. Just like work some sort of like the matching here, right? We are going to get the maximum of this string, which is at the beginning and at the end. So we need to keep track of that maximum string because it's from the 0 from the start. So we can actually just keep the length, right? So let L equals 0, which is just a traverse the needle, and let K equals 0 because the maximum length is 0. Okay, for the first one, there will be no string, right? So it's 0. And for the second one, it's also 0, right? Because there's no, common substring there. And let's just loop it while when it will be in, while else smaller than needle.length. So it's actually both of them are needle, okay? It's kind of like matching them again. Let's say, because first is empty, it's like this. Okay, so next one, if 0, 0, we should not stop 0 because this is already 0, and we are comparing like we're going to compare like ABC, ABG. This one comes from 1, right? Because when we are matched, we're actually determining the jump step of next element. So we start from 1 to determine the 2, index 2, which is the third character. Yeah, so while L start from 1, okay. So if needle L equals needle K, if they're the same, so the next we can determine the jump steps of next one, well, and move them one step further. So L plus 1, K plus 1. Okay, so needle L plus 1 equals, so because we matched K plus 1, so it should be K. Next one, so if they're not the same, like this, if they are not the same, then next one must be 0, right? Next one must be next one. Wait a minute. So if ouch. So next. So wait. Else if like for here, well, first we met AA, right? Okay, so we updated to update the jump step, and then compare BB, CC, AA, BB, and then oh no, it's like this, BA. So it's different because it's at the first. So at the first of the index, so we move to the next one. But if it is not at the index, something like this, we should do just what we did here, is move it to the next possible position, right? This one move. Okay. Anyway, we should first handle if K is equal to 0. If it is 0, then needle L plus 1 equals 0. So there's no chance that it will help. So move it to the next one. Doesn't change the K. For the other case, okay. For the other case, it's like this, right? Okay, doesn't match, 0, match. Okay, from here, it's matched. Let's see where there's the other E. Okay, this matched, and B, G doesn't match. How we should move? like oh, this is not a good example. Like what is the good example here? It's like anyway, it is a match. So, but it may match this one, right? Like if A, B, G, I mean A, B, C, like this. A, B, A, B, G. Like A, B, A, B, G, A, B, A, B, A, B. Like this. If we made something like this, actually, we should move it to here and compare, right? Because A, B matches. So this becomes a sub-problem that you see for C, the jump step is 2. So actually, we need to compare this one. So when this case happens, we need to actually move the cursor from C to A, which actually is just the jump step of C, which is index 4, right? So actually, we should move K to jump step K. And that's it. So the jump step is calculated, and these will cost us OM. Let's run it. Actually, I read a lot of the tutorials. This is actually called hope it pass. This is called actually a very time limit exceeded. God, let's see if there is any mistakes. Console log, jump step. Maybe there is some problem in the while loop. L here, L plus 1, K, L plus 1, K jump to K. So there would be no problems in this while loop, but here, doesn't oh. Log the jump step. I thought that this is not a good, how to say, it's not a very good example to practice a skill. It's like kind of trick. It's called KMP, I think. Anyway, empty. the length is 3 9, so 3 3 10. It's weird. Okay. Ah, God. For L, if they are same, we should, L is already +1 here, so like this. Add extra 1. God. Complexity, this one is much better because you see that is here, it's O N M, but now it's gonna be O N plus M. It's actually called KMP string matching. Please search on that. I didn't solve it by myself, but I read a few materials and try to understand and try my best to explain it in a natural way, but I'm not sure. Ooh. Ah, God. No. I made a mistake here. It should be... Oh, no, it's right. Okay. I'm not the premium member of leetCode, and it's still undefined. Why? Okay, so when we update 2.0, when L is 2, like it's this one, 2.0, it's the same. 2.0. 0, 1, 2, 2, 0. So it's the same. So we should update 1, 2. It's the same. So we update 2. Why it's empty? 1, 1, 2. The console log. Jump step here. One zero. Why there is empty? Okay. So L equals 0. L 0. No. It's different. Yeah, it's different. So it's different. It's gonna becoming, and K is 0. So L become 2. Ah, God. Shit. Wow. Okay. We submit. Actually, I tried this a few times and tried to understand the code. Some of the code on the internet, it just doesn't feel right. It's right, but doesn't feel natural to me. I cannot understand it. A few solutions they will try to make the calculation very concise, which like setting this to -1 and do 2 condition check here. But I think this will suit better for me. And so okay, that's all for this question. Hope we can see you next time. Bye bye.